moderator for this and the following sessions here in this room. I will have an eye on the chat as well, so for everyone who's watching us in the stream, you can ask your questions there. And also, if you're facing any technical difficulties, please reach out via the chat so we can help you out. And I would say we jump right into it, and Alain, the stage is yours.
Thank you very much. Hi everyone, I hope you had a great coffee break now. I'm going to talk about page experience, optimizing page experience in PHP. So first of all, a brief introduction of myself. I generally do software engineering with PHP as the main focus. I'm also a Google developer expert in web technologies, where I'm always trying to be in the know about what is the current best practices for everything relating to web technologies. And I'm currently working with XWP and Google on an interesting project where we try to automate page experience optimizations for the entire WordPress ecosystem. That's an ambitious goal, I know, but we're trying to at least grab a part of the WordPress market and make it better. The talk that I'm going to do here, it is pretty high level. I cannot cover everything in detail. It's a very vast subject matter. But I will try to give a few examples and hopefully show you what you can do on the server side in PHP. But it will focus mainly on that server side, so we will not be talking about bundling techniques with a Webpack and things like that, because everything client, we can't do it from PHP side. So with that out of the way, what is page experience? The page experience signals are something that Google has defined as being important for the end users of the web to have a great experience. And they identified a few metrics that they can measure to find out whether a page is actually a positive and accessible and inclusive experience for users. These metrics, they have tried to keep them as simple as possible and encode them into tools so that everyone can check them for themselves. They are the core web vitals, which focus on three main things. How fast does your page load? And the metric that they are using is the largest contentful paint. So how long does it take before something meaningful actually appears on the screen? Because the user doesn't care about how fast your network stack is if nothing happens in their browser. So it's important that they actually get visible feedback as quickly as possible. Then there's the interactivity, the first input delay. How long does it take before the user can actually click on the web page for it to do something, for the buttons to actually react to the user input? And then the visual stability, that's the cumulative layout shift. And I think everyone has had the experience of loading a web page, and then you want to click on the navigation only to have an ad appear at the last moment, and you click on the ad or things like that. So if the page jumps around all the time, that's very frustrating for the users. And a cumulative layout shift measures that instability, and you want to get rid of that completely and have a stable visual layout from the get-go. So these are the core web vitals. And then the site should be mobile friendly. It should be sent over a secure protocol, and there shouldn't be any intrusive interstitials. Meaning that all of a sudden a pop-up jumps in front of you and or you're redirected to another page, things like that. So all of these are being measured by Google constantly, and they are now a ranking factor to decide how far up the top of the search results your page can actually get. If your page experience is bad, Google does not want to present it to their users, because it only wants to show the best possible sites, and that is not the content alone, that is also the user experience. Before we head into the actual optimizations, a quick note about how the web actually works. It's probably not news for most of you at least. the web is basically a client-server architecture. And what we have is, in a traditional setup, we have a server that gets a request and then builds the end result to show in the browser, and then sends it over to the browser. And the links in that page, they create the next request for the server to build the next page. So that's how a traditional stack works. In that scenario, the state of the site of the app is stored and managed on the server. That means that we have a lot more contextual knowledge about the site on the server. In a more modern stack, we end up with something like this, where the server sends an application in JavaScript to the client, and then everything runs on the client until they are being redirected somewhere most of the time. So in that case, all of the state and most of the rendering happens on the client, and the server does not have a lot of knowledge about what is actually being shown. As we are focusing here on server-side optimizations in PHP, in such a modern stack, of course, you have less opportunities to do the optimizations in PHP. It will require heading more towards the JavaScript optimizations, which we won't cover here. So keep that in mind. If you're building an SPA, most of the time what you end up building on the server is just a shell, a very hollow shell that you send over with a link to the actual app to be executed in the browser. And then in that case, there's no hope of doing proper optimization in PHP. So with that out of the way, let's talk first about the three main units of optimization that you're dealing with in PHP on the server. First of all, we have the HTML optimizations, optimizations of the actual markup. So what you're sending over is a page of HTML, and there's a lot of things you can do on the server side. You can rearrange stuff. You can change the prioritization of when what happens, which allows you to decide. For example, if you look at the largest contentful paint core web vital, it's important to prioritize all the things that go into that largest contentful paint and not waste a lot of time on the footer of your page, for example. You can pre-compute stuff. That is where things like server-side rendering come into play. So instead of building very minimal HTML, you can actually do all the work that normally happens in the browser already up front on the server to reduce the cumulative layout shift. You can inline stuff so that instead of doing an additional remote request to download an asset like a style sheet or a script, you can actually inline that so that it is immediately part of the markup and it gets sent with the first request. You can implement workarounds. There's a few things that happen automatically in browsers that are actually not very useful for you if you want to have the fastest possible reaction for the user. A famous example is if you configure your viewport with the default settings that are usually told as being best practices. What happens is you define a minimum scale for the web page, maybe other metrics for the viewport, and then your browser will assume that your device then supports tap to zoom, for example, and it will always include a delay before a click is being accepted because it wants to check whether it is a double click to zoom in on the page. So you need a workaround in that case to get rid of that delay to make the first input delay faster for users. Because if there's no need to zoom, then waiting for a double click to potentially zoom when that is blocked anyway will not do anything good. And then finally, we can communicate intent and priorities to the browser. That is commonly done with resource hints, for example, where we have more knowledge than the browser about what is important on the page and what is not so important. And if we tell the browser what the actual intent of the page is and what the actual priorities are, it can then do a better job of doing parallel downloads where they matter most and prefetching things. Then we have linked assets optimizations. So what we have is we send HTML markup that represents our page or application, and that contains links to everything that cannot be expressed in HTML. That is style sheets, that is scripts, that are images, and all of these linked assets, they can also be optimized. They can also be optimized on the server. You can, for example, re-encode your images to take up less space, which means that they will be transferred faster to the user's browser. You can optimize the styles, the scripts in different ways by minifying, by tree shaking, doing all sorts of reduction mechanisms. You can also inline some of these assets, as I already mentioned for the mockup part. For example, SVG elements, if you have icons on your page, instead of having 30 separate external requests for such small assets that can be highly optimized in terms of their byte size, it makes sense to just, excuse me, it makes sense to just inline them so that they don't need to be downloaded separately with separate requests. Just a second, please. Excuse me. So and then we have headers optimizations. The headers are also sent as part of the response. So the HTML is the body of the response, and then we also have the headers. And there's also a lot of optimizations we can do there. We can control the caching strategy, for example. So doing things like always having a full page cache intact, doing a stale while invalidate caching strategy, where while the cache is being invalidated and refreshed, we just serve the stale content from the cache because we know there's nothing time critical about the page. Things like that can be expressed by the headers. But we can also include resource hints in the headers, which makes them even faster. So before the browser even gets to the HTML, it already knows which will be the header image that is very important for the largest contentful paint. So it already starts downloading that in parallel with the HTML that it's trying to parse. There's also some protocol features that you might be able to add to your page, or security features which make it so that the browser can further optimize some of the requests. What we're focusing mostly here now for the rest of the talk is HTML optimizations. You can, on the server side, you can do also a lot of the asset optimizations, but the thing is that most of these require specialized tools, and what tools you're using highly depends on the server stack that you're using. And oftentimes it is even not the best idea to do these kinds of manipulations on the server because they can be very expensive and can cost a lot of resources on your server, which then makes your server slower to do its actual job of serving the pages. So if your server transcodes your images all the time, it will be slower of serving the pages. So that's why we will not focus on that area here, but it is possible to do it on the server. But I would recommend outsourcing that to a different server or a service that you can use. So for the HTML optimizations, I want to talk about a few examples. First of all, we have the resource hints. This is a very important tool set for managing how your page loads in the browser. So if you load your page with developer tools in your favorite browser open, you will see a kind of waterfall diagram of how it loads which resource. You will see how long the resources take. You will see which resource it's blocked by which other resource. And one of the cheapest optimizations to do is look at what is the most important to get to the good core web vitals, the largest contentful paint, for example, to lower that, and then prioritize these elements so that the browser knows to download these first before we're dealing with downloading the background JPEG for the footer or things like that. So it's very important to communicate with the browser and let it know how best to do things. And then it can do its job best. We have DNS prefetch, which allows you to actually resolve the domain names upfront. So for anything that if you download your fonts from a separate server that runs on a different domain name, it makes sense to already connect to that domain. So you can either just resolve the domain name, or you can do the pre-connect, which even does the entire handshake of establishing a secure connection. However, the pre-connect is not supported by all browsers. That's why usually you combine these two. Most of the time, it just makes sense to try to do a complete pre-connect for these cases, because you will need to do the connection anyway. But you will then do the DNS prefetch as a fallback for the browsers that do not support the pre-connect, so that at least the domain name is already resolved. Then we have the preload and the module preload, which are not actually resource hints, they are browser directives. They allow you to force downloading an asset resource that will be needed in the current page. So with the preload, you can, for example, if your page has a big hero image, you can try to preload that hero image as soon as possible. It will be done in parallel with all the other stuff that happens in the browser, but you want to start as soon as possible so that when you get to actually displaying that hero image, of rendering it, painting it in the browser, ideally it will already be loaded. The module preload is the same thing for JavaScript resources that use the new ECMA script modules standard, so that you can actually preload all the different modules of your JavaScript application that you need. And then we have the prefetch, which is more of a risky proposition. With the prefetch, you basically try to preload the next page that the user will land on. If you have a flow where it makes sense that the user clicks through a sequence of pages, for example, you can already prefetch the next page so that it is available once the user clicks on the button. But if you have a complete navigation that the user can click on, it doesn't make sense to prefetch everything. That just wastes bandwidth and will not be faster at all. It will just be more costly. And bandwidth is also something that you always need to consider, that not everyone has fast, cheap internet connectivity. So in some countries, people literally pay per kilobyte that they download. So always be mindful of not doing potential optimizations that actually waste bandwidth. With the resource hints, you can do them either in the headers. That is the earliest that you can communicate with the browser. So you can do a link entry in the response headers, but most of the time you will end up doing them as link tags in the document's head element. So here you can see an example of a preload, how that looks. You preload as a script, so that as script tells the browser what that is supposed to do as type of resource. And then if that resource later is being referenced to actually use it, if it has not been preloaded yet, it will be done on demand, but hopefully it was already done as the preload and the preload completed, so it will basically just be in RAM when you actually need it. And then here we also have an example with a pre-connect, and as I said, best practice is to combine these two in this order, as I'm showing, so that the pre-connect will be used by the browsers that support it, and the fallback is a DNS prefetch if the browser does not support it. Then another way of optimizing is to do lazy loading. The general principle is that as long as something is not needed to be displayed to the user, there's no need of actually downloading it. There's other things that might take priority. And also, if you have a page that contains hundreds of images, the user might not actually scroll down. So downloading all of these images wastes a lot of bandwidth again. And it makes sense to only download those that start to enter into the viewport of the user. So while the user is scrolling, you check where the user is within the viewport and how far away the elements are, and then start downloading them once they reach a given distance threshold. By now there's browser support for that, for images mostly. So you can actually add a loading equals lazy attribute to an image, and then the browser will just know what to do. It will properly check the viewport and download as needed when things enter into the viewport. And this is much better than all the libraries we've had before, because this also works reliably if JavaScript is disabled. So this is just a safe optimization to do, provided that you're working on modern browsers as a target. It has pretty good browser support for images. However, it is supposed to also work for iframes, but for now, iframes only work in all the Chromium-based renderers. And Firefox, for example, only supports image lazy loading and not iframe lazy loading. Hopefully that will be addressed soon, because iframe lazy loading is also very powerful. Imagine a site that is an index of your YouTube videos, or that has 20 Twitter embeds included. Right now, everything is just downloaded in the background and might never be needed. And lazy loading for iframes will then also just download all of these things once they enter into the viewport. Then we have tree shaking. That's also something you can do right away from the server, provided that you have the full page available. So with tree shaking, the main principle is that you pause all the CSS and you look at what is being used by your HTML markup. Because normally when you write your CSS, it is written for the entire application or the entire website, and it includes a lot of stuff that is only used on certain pages, or that is only used under certain conditions. And the tree shaking means that where it makes sense, instead of sending all of the CSS, you're only sending a small subset, only the very bits that are being used by the browser. In that case, you always have to do the trade-off between having adapted CSS per page and using caching, because the entire CSS remains the same across all the pages. So this is something you need to decide whether it makes sense for your use case or not. For static pages, if they don't use a lot of CSS, you can actually inline the CSS and have the entire thing be sent in one go. But that only makes sense if the CSS is as small as possible. And that's where tree shaking becomes very powerful. So oftentimes tree shaking is combined with then inlining the result into the markup. Keep in mind that when you're tree shaking, you need not only look at what the markup is doing, but if you have JavaScript scripts active, you also need to consider whether they might be adding or removing classes or doing other DOM manipulations, where the selectors might not fit on the standard page, but might need to be included nevertheless, so that they work with the interactivity. Oftentimes, this is just a kind of allow list where you add a certain set of classes, for example, that when they are being used in selectors, these selectors are always included in the tree shaken CSS, even if they're not encountered in the HTML. Yeah, the basic principle is pause CSS rules and then look at where the selectors match the HTML. For pausing the CSS rules in PHP, there's a library that is pretty complete and is constantly being maintained, which is the PHP CSS parser by Zaberworm. I hope I'm pronouncing that correctly. Then we have server-side rendering. So server-side rendering is a very interesting concept, and oftentimes there's lots of discussions around how super useful or how ridiculously meaningless it actually is based on how you define it. So technically, whatever you produce in PHP is server-side rendered HTML in the end. So adding server-side rendering as a concept doesn't necessarily make sense. What is meant by server-side rendering is that whatever additional computations usually would happen in your browser, because they are dependent on certain contextual elements, you move them to the server to emulate what the browser would do, so that the browser does not have to do that work. And oftentimes that means that if it is already done, it will reduce some of the problems that you face when you want to optimize the core web vitals. The main culprit you usually want to optimize with server-side rendering is CLS, the cumulative layout shift. So with server-side rendering, instead of having an image that you're just hooking up to the page and then letting the browser figuring out while it downloads the image, rearranging everything to make sure that the image fits properly and that it is responsive, you actually want to have a static layout that is served by your server. So on your server, you examine the image, you examine the aspect ratio of the image. You include fixed sizing where it's possible. You include placeholder elements where it is not possible to include fixed sizing. What is often done, for example, is using base64 encoded inlined SVG elements that are basically empty, but they contain a fixed height. And that is then being used to force a certain aspect ratio of an element or reserve a certain space for an element while it is being loaded. So in that case, you can hardcode, you can turn your dynamic layout into a static layout where once the HTML markup is downloaded, the entire main layout of the page is already figured out. It is already fixed. And while the browser is then downloading the elements, it does not need to recalculate the layout. It does not need to repaint the page. It's just filling up the spots that you left empty for it. That's basically what is mostly understood under server-side rendering. I'm not including examples here because usually it involves a lot of code. But as I said, one common technique is to pre-calculate all the layouts, include width and height attributes wherever it is possible. Even if you don't have a unit, these width and height attributes already let the browser know what the aspect ratio is. So as soon as the browser knows the width of your page, it can guess the height of your elements if it has the aspect ratio. And in cases where you cannot provide these for the element itself, it makes sense to have a container with a placeholder, like for example with such an SVG that you inline. It's just it's a very simple XML file that you then base64 encode with the dimensions, and if you inline that, the browser already reserves that space, and when you then download the element that goes into it, it does not shift the layout around. Now a bit of historical context to first let you know why I have been working a lot on that, and then I'll be getting to something more interesting. First, I'll take the dirty AMP word in my mouth. So some people have very strong opinions about AMP. I've been working on a project for a while now to automate the transformation of WordPress pages into AMP-valid pages. And while you can discuss how good or bad AMP is, in average, it improved the result of WordPress pages by a lot, because WordPress pages tended to be very awful for the internet. And the end result that you got when you install 50 plugins on your WordPress site is usually not very user-friendly and very wasteful for the internet. So the goal was to, on average, improve the internet for whole by making by making use of the leverage of WordPress as an established platform. That project has ja, ich habe was zu trinken, danke schön. So, ich will ja nicht trocken rüberkommen. This project produced some tooling in PHP to automate a few of these things, and one of these was the AMP optimizer that is part of the AMP toolbox repository. And the AMP optimizer, it is basically a pipeline where you put HTML in and you get better HTML out. And it does a lot of things that are specific to AMP, like replacing a Twitter embed by an AMP Twitter component, for example, which then automatically includes lazy loading and things like that. But it also included a lot of optimizations that make sense no matter what, whether you're using AMP or not. The problem was that the entire project was really focusing on AMP at the time. And so it was all built into this AMP workflow. I have been working for a while on extracting everything out into separate PHP libraries, but then at one point we tried to rebrand that effort. Instead of having a plugin that turns your WordPress into an AMP site, the idea was to instead have a plugin that improves the page experience for your WordPress site. It might use AMP if you want to do that. It might use other things, but in general it will just be an improvement no matter what, and you decide which technologies you want to use. And that has become a complete rebranding effort for that plugin, but it also means we have now started with a new package, which is the page experience toolbox. It takes a lot of the concepts that we learned with the AMP approach and tries to apply it in a more generic way to create a library that lets you optimize the page experience for any website, for any application that has PHP as the main server language. So while we're building that to include it in a WordPress plugin, it is built in such a way that it can easily be included in any Symfony project, in any Laravel project, on a Magento site, or wherever else. And one of the core principles is that it will, by default, do all the safe optimizations it can do and not break your site, and then you can manually trigger more optimizations or get recommendations of what to improve manually to further improve your page experience. So this is the repository URL under GitHub. It is right now in a very early state. So we're basically just migrating most of the tooling over now to this new repository. But the core architecture of the library is that it is basically an abstraction that is above the tooling that uses it. So where with the AMP optimizer we had an AMP optimizer tool, then we had an AMP validator tool, and then we had an AMP sanitizer tool. Here, this package, it builds the page experience engine, and that is meant to be an overarching wrapper across arbitrary tooling with adapters that allow you to normalize the results you get from these tools. The main reason why we are doing that is because we want to build the user interface in the plugin only once and not adapt it with every tool we add to the arsenal of the toolbox. So everything is normalized, and the engine, you can configure it with what tools to run, and then it makes sure that all of these run as fast as possible and then produce results. It can both analyze your pages. This might not be that interesting for automating your server stack, but it might come in handy, for example, to include that in a CI pipeline. So if you have a project where you always run tests through your CI before doing deployments to a production server, you could include that and have thresholds in place, or make sure that you're not getting new issues that are being found as performance problems on your site. And then it has two ways of optimizing in a fully automatic way. One is to optimize the HTML that works on a string. So you put generic HTML in, you get optimized HTML out, and it can also use a PSL7 response object. So while WordPress does not really support these standardized interfaces, we're building everything for the overarching PHP ecosystem and then adapting it for WordPress as needed. This approach will also allow the tooling to optimize the headers as well. So it will be able to have access to the complete response and then optimize the response as needed. For now, this is still heavily work in progress. Unfortunately, it cannot be used yet. We want it to be a bit further down the road right now. We want to have a first prototype working. We're not yet at that stage because rebranding a plugin and its entire ecosystem is quite the effort, and we're still dealing with the aftermath of getting the last release for the rebrand out. So that has taken up a lot of resources. But the architecture is already in place, and we're building first testing data now to do initial runs. And I wanted to present that project here because I think that a lot of the stuff that I cover today should not be every single web developer's problem. It should be something that we can solve as a community together once and for all, and then have most of these bad practices be solved. And AMP tried to do that, and with AMP it was a bit of a forced approach. So AMP, one of the concepts with AMP was that it runs everything in a sandbox. So you're actually not allowed to do it wrong. And while that did not always produce the very best optimized solution, it most of the time was able to guarantee that you're not hitting the worst offenders. Now with this page experience engine, we want to get away from AMP, but we want to keep some of these principles intact. And while we don't want to enforce the sandbox, we want to incentivize it and basically have a library that can do all things like the workarounds that I told you about with the viewport or a lot of the server-side rendering. Most of that is just the same for every single website. It can just be automated away. And then for all the other things, you should have prioritized recommendations that tell you what gives you the best impact, best bang for your buck when you do manual optimizations. Where should you look first? And the sandbox that AMP was trying to enforce, that is basically the incentivized end goal that we want to recommend towards with the page experience engine, where most of your page ends up being static, pre-computed, and very fast for the browsers to work with, and with none of the bad surprises for the visitor that some of the current approaches yield. So hopefully, with this new engine, we will be able to find collaborations with other systems in the PHP space, so that we can all collaborate towards PHP being a good citizen of the web and actually producing the very best results consistently. That's it for the talk. I'm now available for questions. Yes, please. Yes, so the question was whether the resource hints, the pre-connect, preload, and so on, whether they are supported by all the browsers. Most of them are supported by all the modern browsers. So with modern browsers, nowadays, it basically means everything based on WebKit and Firefox Safari. Yeah, the Internet Explorer is based on WebKit as well by now, so that is included there. And most of them are supported by all of these, except for the pre-connect. Pre-connect still has a few cases where it's not supported. That's why the best practice still is to combine the pre-connect always with the DNS prefetch. But the preload, for example, that is a browser directive that's normally supported by all of them. They might have different results in different browsers. So sometimes browsers handle them differently because as the name resource hint already tells you, it is not, the preload is a directive, but the others are hints, and they only hint to the browser what might be a good way of doing it, but the browser is free to decide otherwise if it thinks that that makes sense. So it always, it's worthwhile testing from time to time whether your assumptions are always correct across the browsers. But most of the time with the worst offenders, like trying to preload the hero image on your web page, for example, with most of these, it is usually a safe bet, and you can reliably do that across the browsers. Thank you for your question. Do we have any other questions? Yes, please. Yes. You said that you're agreeing with everything except for inlining the styles in the HTML. The thing with inlining the styles in the HTML is, as I already said, it's a trade-off where you really always need to see the bigger picture of what your actual use case is. And with inlining the styles, you might be able to have a fully static, fully declarative page that can actually be fully served by CDN nodes and never needs to do a connection away from these CDN nodes. And a page that includes everything in a way that it doesn't need to connect to other origin servers can actually be cached and transferred from other servers so that they pretend to be the origin server. A good example for that is the technical constraints that AMP had in the beginning. So the idea was that AMP pages are static, so they can be sent by a cache instead of hitting the slower servers with a slower network stack. So in the beginning you had the Google AMP cache, the Bing AMP cache, the Cloudflare AMP cache. They were all trying to serve these pages because they had faster networks and cheaper networks that were spread around the globe. But the problem was that they could never pretend to be the origin server, so you ended up with these weird URLs where it was not your domain anymore when you clicked on a search result on Google, but it was the Google AMP domain with your page attached to it in some form of URL argument. But that was solved by implementing signed exchanges. And the signed exchange is that you can take a piece of a web page and sign it in such a way that anyone can take that signed piece and serve it instead of the origin server without any security issues, as long as the signature stays intact, as long as the site was not tampered with. And that allows, for example, for worldwide caching systems to serve complete websites, provided that they don't need to make additional connections outside of that cached space. And in such scenarios, including the CSS in there makes sense, because the CSS will be part of the signed package, and it cannot be tampered with. As soon as you have an external remote request, even if it's to another CDN server, that signature, that signed exchange cannot work anymore. And so you cannot cache the entire thing to serve it instead of an origin server. I hope that explains one use case where it does make sense to inline the styles. And of course, you always have to take into account how much CSS you have. And for example, had a strict limit of 50 kilobytes max of CSS for the entire page. Everything was then inlined, but that only worked if you were below that 50 kilobyte limit. If you were 1 byte above that 50 kilobyte limit, it was just invalid AMP. Of course, size is a constraint there. Thanks for the question. Anyone else? No one? Nothing from chat? Okay, thank you very much.